Hello everyone. Today we're going to talk about Newton's method. Newton's method was a way to find zeros before we had calculators that could do it for us. So for example, if I want to find the root, the zero, the solution, the x-intercept for this equation, okay, if you try to solve it, you're going to get irrational numbers. You can see here it crosses somewhere between 2 and 3. So how can we find what the root is to a close decimal approximation? Well, the method will find this. We've got to have some basic knowledge first. For example, at a root, f of x, or the y value, is equal to 0. Okay? The method is guess a number close to the root. Find an x value that you know is close to 0. Now, we're going to use our calculators. Before calculators, they would just plug in a number and see which one would give them a y value that was very close to 0. This is the actual formula. I'm going to say guess, which is an x value, minus f of the guess, which is the y value, over f prime of the guess, which is the derivative or the y prime value. And then that's going to give you a new guess. You're going to then use that new guess and plug it back into this formula. And you're going to keep repeating until the f guess, the y value that you're getting, is almost 0. Now you can go forever and it'll just get more accurate and more accurate and more accurate. But for the sake of this problem, we're only going to do it to 3 steps. Okay? So, here's the problem we're going to work on. I cheated and went ahead and wrote the answers down first so I didn't have to work out every single part of this problem. Here's the problem we looked at. Here's the method. If you remember, we knew that this crossed somewhere between 2 and 3. So I'm going to let my first guess be x equals 3. Okay? So let's plug it in. The guess is the x value minus. Instead of doing this by hand, we're going to do this on the calculator. The equation was y equals one half x squared minus 3. And let's graph that. Let's get a normal looking graph, zoom 6. So I need the y value and I need the y prime value. I need the value of the function and the derivative of the function at the point 3. The calculator will do both of these for you. Second trace 1 will give you the value. I want it at 3, and it's 3 halves, or 1.5. So I'm going to plug in 1.5 right here. Now I need the value of the derivative at that point. Obviously the derivative of this is just going to be x. I'm choosing a simple problem, but let's pretend like it's a much more complicated problem, one where we can't easily look and see the derivative. The calculator can find the derivative for you. Second trace, derivative is 6. I want it at the point 3, and I hit enter, and it tells me it is 1.5. No, I'm sorry, it tells me the derivative is 3. So the derivative is 3. Now I'm going to type this in my calculator. Again, I know these are easy numbers and we can do it without the calculator, but I want to practice using the calculator. Get out of the graph, and we'll say it's 3 minus. Let's put in a fraction bar. 1.5 over 3. So the first answer is going to be 2.5. My new guess is 2.5. Now the new guess becomes the guess. I follow the same pattern. 2.5 minus. I want the point at 2.5 and I want the derivative at 2.5. So I go back to my graph. Second trace. The value at 2.5 is 0.125. And the derivative at 2.5 is 2.5, which makes sense because the derivative is just x. So it's 0.125 2.5. Again, we could calculate this by hand if we wanted to, but there's no need. We have a calculator to do it for us. 2.5 minus alpha 1 equals 1. Put the fraction bar in. 0.125 over 2.5. And it gives us 2.45. So 2.45 is my second iteration. We're going to go through one more time. You can go as many times as you need to. Sometimes it'll say go to 3 iterations or 4 iterations. Sometimes it'll say go until you're within 3 decimal places or 6 decimal places. So this is my new guess. This is the value at 2.45. This is the derivative at 2.45. Again, I'm going to use the graph on the calculator to answer this. The value at 2.45 is 0.00125. So we're getting very, very close to 0 there, which means we're getting more accurate. And obviously, the derivative at that point, since we know the derivative is just x, the derivative is 2.45 as well. Again, not every problem will have such an easy derivative. We're just starting out with a simple example here. And I'll save you some time. If you type this in the calculator, well, let's just go ahead and do it. You do 2.45 minus, put in your fraction bar, 0.00125 over 2.45. And it's about 2.449. So I'm going to drag that out here just to have a reference for later. So to 3 decimal places, which is good enough for now, 2.449. And I'm going to stop there. You could continue going. But thankfully, we have calculators that can do this for us. We don't have to guess. So let's figure out where it actually crosses the 0. Let's find the 0 in the root. I'm going to put in 0 for y2 and graph it. I'll let it graph. I'm trying to find where these two things intersect. So second trace, 5. Let's move over close to where it intersects. Hit enter 3 times. So, with our estimation, it was 2.4494897. Our calculator says 2.4494897. With only, 3 iterations, we got to within 1, 2, 3, 4, 5, 6, 7 decimal places. Very, very, very accurate. So, some limitations. If you're looking for this root, don't guess close to this one. It'll take you to that root. Also, occasionally, they fail to converge. Sometimes your guesses don't get closer to an answer. And you'll know that because the y value on top isn't getting smaller. If this happens, pick a different guess. Okay? So Newton's method again, it's a way of finding zeros. There's a formula that you have to know, but your calculator can do all of the work for you.